fall using all my videos. So that'll be cool if I remember to do it. Okay, so we don't need that, we don't need this, we don't need, there we go, I'm all set. So we're in, this is the second class in a row where we've finished off the last section of the book. We did that in the devices class this morning, and now we're doing it in this class the afternoon. So that, considering that you guys have never been in a class where we finished off a book, you know, to have that happen is kind of amazing. We still have some other useless topics to talk about next week, so but it's kind of cool.
Just did a review next week, then?
No, we're not going to review for the test next week. Oh, what a waste of time that would be. Total waste of time. Anyway, number 4. Oh, this is pretty simple. Alright, so I got y prime minus 2y, doesn't look much like a 2, is equal to 0, and y at 0 is 5. Alright, so I'm going to take the Laplace transform of these guys and say s y of s minus 5 minus 2y of s is equal to 0. So where's my Laplace transform table? Alright, so I'm using number 2 to do the y prime, so that's sy of s minus y at 0, which is where the 5 came from. Alright, now I'm going to combine like terms. S minus 2 y of s is equal to 5, and then y of s is 5 over s minus 2. Then I'm going to do a inverse Laplace transform of the whole thing, and I'm going to get y at t is equal to, and then I'm going to look at my Laplace transform, and I'm going to say that this is number 7, and I'm going to get 5e to the 2t. And then I'm going to check my work, and I'm going to, so that's my final answer right there, in case anybody was wondering. Y at 0 is supposed to be 5. Check. It is. Y prime, let's see, y of t is 5e to the 2t, and y prime is 10e to the 2t. And I'm supposed to have one of them and minus 2 of these, and when I get done I'm supposed to have 0, and I have 10 minus 10 is 0. Check. So is that pathetically easy?
Yeah.
Yeah, it was more than pathetically easy. Number 8. Y double prime plus 3y is equal to 0. I have y at 0 is 2. Y prime at 0 is 5. And I'm going to take the Laplace transform of the whole thing. S squared y of s minus s y at 0, which is 2s, minus y at 0, which is 5, plus 3y of s is 0. I've got s squared plus 3 y of s is equal to 2s plus 5. I have y of s is 2s plus 5 over s squared plus 3. And now my plan is to take the inverse Laplace transform of both sides. So that's the plan. Looking at my Laplace transform table. Something s squared plus something with a k on top is number 8, and the s on top is number 10. And do we have both an s and an 8 on top? Not really. Okay, so we're going to have to rewrite this and say y of s is equal to 2 times s over s squared plus 3. plus, if 3 is k squared, then I need a square root of 3 on top. So I'd have 5 divided by the square root of 3 on the outside, s squared plus 3. And then I would see that this is number 10, and this guy is number 8. And now I'm going to do my inverse Laplace transform. And I'm going to get that y of t is equal to 2 cosine square root of 3t plus 5 over the square root of 3 sine square root of 3t. Okay, now I'm going to check my work. Y at 0 is supposed to be 2. It is. Check. And y prime is minus 2 the square root of 3 sine square root of 3t plus 5 cosine square root of 3t, and y prime at 0 is supposed to be 5. Check, it is 5. So our initial conditions work. Do we need to check the rest of the problem, or do you trust me that it's right?
I trust you.
So we'll assume that that is going to be correct. And now, why don't we go and revisit that problem? That was number 8. So we're going to revisit number 8. Y double prime plus 8. Y plus 3y. 3y is equal to 0. Y at 0 is 2. Y prime at 0 is 5. So we're going to revisit the problem and say, well, gee, this has a characteristic equation. M squared plus 3 is 0. M is going to be equal to plus or minus the square root of 3i. So y of t is going to be c1 cosine the square root of 3t plus c2 sine the square root of 3t. Then we would apply the initial conditions and say y at 0 is 2, which is going to be c1. So now we have c of t is equal to 2 cosine square root of 3t plus c2 sine square root of 3t. And then we'd go and take the first derivative of y prime of t, 2 square root of 3 minus sine square root of 3t plus square root of 3 c2 cosine square root of 3t. Y prime at 0 is 5, which would be square root of 3 c2, implying that c2 is 5 over the square root of 3. Final answer, y of t equals 2 cosine square root of 3t plus 5 over the square root of 3 sine square root of 3t, which is the same answer that I got doing it the other way. So now the issue is that an easier way or not? And that particular problem is 6 of 1/2 does the other. Probably doesn't matter either way. But I did get the same answer, so that's all that really matters. Number 8 and number 12. Y double prime minus 6y prime plus 9y is 0. Y at 0 is 1. Y prime at 0 is 2. Now, what physical problem is a second derivative problem? Well, two that come in mind. One is a spring. So if I pull a spring down, it has an initial position. Y at 0 is 1. It has an initial velocity if I push it up 2 with an initial velocity. So y prime at 0 would be the initial velocity. So it'd be a spring problem. It could also be a RLC circuit problem. So an RLC circuit is also a second order differential equation, in which case y1 would be the initial current flowing and y2 would be initial charge on the capacitor. Okay, well, enough of that. So these things do have real world meaning if we were to choose to find it. I'm going to take the Laplace transform. I get s squared y of s minus s minus 2 minus 6 times s y of s minus 1 plus 9 y of s is 0. And then I would have s squared minus 6s plus 9 y of s is equal to s minus 5 minus 4 minus 4. I don't know. Minus 4. So I got minus 2, which becomes a plus 2, and then I got a plus 6, which becomes a minus 6, so I'd have a minus 4. Notice that the s squared minus 6s plus 9 looks very similar, if not exactly the same as the characteristic equation. Obviously for good reason. S minus 4 over s squared minus 6s plus 9. S minus 4 over s minus 3 squared. Alright, so we look for a s minus s squared, s minus something, quantity squared. Right, so I see it as a 17, and I see it as a 15. So I see this guy as 17 and 15. So I'm going to rewrite him. Y of s is equal to s over s minus 3 squared minus, okay, so that'd be the 17 guy, and 4 minus 4 1 over s minus 3 squared, and that'd be the 15 guy. Alright, now we take the inverse Laplace transform of everything we see. Y of t equals 17 e to the at 1 plus at. Well, let's put the 1 in. Let's put the a in. Right, so I need a is minus 3. So e to the minus 3 t 1 minus 3 t minus 4 times number 15, which is t e to the minus 3 t. Alright, so I got e to the minus 3t minus 7t e to the minus 3t. Alright, now we're going to check our work. Y at 0 is supposed to be 1, and it is 1. Check. Y prime of t minus 3 e to the minus 3t minus 7 e to the minus 3t plus 7t e to the minus 3t. Y prime at 0 is supposed to be 2, and we have 10. Shit. How did that happen? Back to the top. there's a minus s, a minus 4, an s squared minus and minus 9, minus 9. That is s minus 3 squared, right? S minus 4, minus 4, t to the minus 3 minus 1 minus 3t minus 4 times t e to the minus 3t.
Would be 1 plus 3t?
No. Yes, 1 plus 3t. And this is a plus as well. And this is a plus as well. We're still stuck with that minus 4 though. Okay. That makes this a minus 1. Plus 3 minus 1. So that makes that a minus 1. And this guy's still that. And now the derivative minus, this is plus, that's plus, this is plus. Okay, so that's 3, that's t, now 7, and this is a 3 over here. Okay, now I have 2. Check. That'll teach me. And now we're going to do 18, 19, 20, and 21 and call it a day. If I last that long. Do we need any more chocolate chip cookies, or we Girl Scout cookies, or we had enough today?
Enough today.
All right.
That's these guys.
They don't count. First guy, the only guy that counts is the guy that answers first. Damn it, there.
Sorry.
2 and 3. See, we could have questions like this on the quiz ball stuff, right? Alright, so I got s squared y of s minus 2s minus 3 minus s y of s minus 2 minus 2y of s equals 0. S squared minus s minus 2 y of s equals 2s. The 3 minus 3, but there's a plus 2, so that'd be a plus 1. Y of s 2s plus 1, s squared minus s minus 2. Looks like that factors to me. Y of s, 2s plus 1, s minus 2, s plus 1. And now we'll look at our Laplace transform table to see if we have that guy. And well, not exactly. Okay, what I would do on this particular problem is I would do a partial fraction and say that this guy is going to be equal to a over s minus 2 plus b over S plus 1. And then I'm going to go and find a common denominator and say AS plus A plus BS minus 2B has to equal 2S plus 1. And then I look at the S term and say S plus B has to be 2, and I'm going to look at the unit term and I see that S minus 2B has to be 1. And then I say, well, A has to be 2, 1, 1 minus 2 divided by 1, 1, 1 minus 2. Minus 4 minus another 1 for minus 5 divided by minus 4 divided by minus a 1 for minus 3. So A is going to have to be 5 over 3, which implies B is going to have to equal 1 over 3? 1 over 3. And that checks in the first guy, and that checks in the second guy. So my y of s becomes 5 over 3 divided by s minus 2 plus 1 over 3 divided by s plus 1. Yes, it does. Then I do an inverse Laplace transform, and I'd see that this is number 7, and this guy's number 7, and I'd say y of t is 5 thirds e to the 2t plus 1/3 e to the t. Alright, that would be my final answer, assuming that it checks. Y at 0 is 2, check. Y prime would be 10 over 3 e to the 2t plus 1/3 e to the t. Does it just piss you off? Pisses me right off. Y prime at 0 is 11/3, which is not 3. Oh well, can't have everything, right? Alright, back to the top with the red pen. Problem was written down properly. The Laplace transform is done correctly. S squared minus s minus 2 is correct. 2s goes that way. I have a 3, and a minus 2 is a 1. That's correct. Does this factor that way? Yes, it does. Okay, it factors that way. Blah, 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 that's correct. Same problem there. A plus b has to be 2. A minus 2b has to be 1. 2, 1, 1 minus 2. Minus 4 minus 5. Minus 2 minus 3 for a 5 over 3. If this guy's 5 over 3, that has to be 1 over 3 in order to be that. Alright, okay, that's fine, that's fine, that's fine. How come
The s plus 1, would that be minus 1?
there we go. Minus t, exactly. Minus t minus, not plus. And then 9 over 3, which is equal to 3, check. Alright, excellent. Now we'll do the electronic problems, number 19. Okay, so we have an inductor, 2/10 of a Henry. We have a resistor, 20 ohms. We have voltage, 12 volts. We have I at 0 equals 3. Okay, so that's what we have. And so we have a battery, resistor, and an inductor. The voltage across the resistor is IR. The voltage across the inductor is DI DTL. And that guy's 12. So, that being the case, I have, no, I can't see it, 2 tenths I prime plus 20 I is equal to 12, and that I of 0 is equal to 3. And I remember that. Okay. Take the Laplace transform of those guys, and I have 2 tenths I of S minus 3 plus 20 I of S is equal to 12 over S. Now you probably forget that 12 over S, but that is number 4 on our Laplace transform table, and you can't forget the S. Well, you could forget the S, but if you did, you'd be hosed. Alright, so I've got 2 tenths S plus 20 I of S is equal to 12 over S plus 6 over 10. I of S equals 0.6 S plus 12 divided by S times 0.2 S plus 20. I probably don't want those points, those things sitting in front of the S's, do I? Okay, so if I have S plus 20, that looks like number 13. And 14. So those are number 13 and 14s. If I multiply the top by 10 over 6. Okay, so if I multiply the top by 10 over 6, and I multiply them by bottom by 10 over 2. Okay, so I could do that, but if I did, I'd have to multiply this by 2, 6. So I'd have a 2, 6 on the outside, and 2, 6 times those guys give me 1. So that'd be good. So I have I of S 2 over 6. I'm going to have S plus 20. 20? S plus 20 divided by S times S plus 100. So that's what I've got. I'll probably do a partial fraction on that after I blow my nose. That's probably what I do. So I'd say A over S plus B over S plus 10. S plus 100. So I've got AS plus 100A plus BS has to equal S plus 20 I have that, look at the S guy, I have A plus B is 1. Look at the unit guy, got 100. A is equal to 20, clearly implying that A is 1/5 and B is 4/5. So I've got I of S equals what? 1/5 over S plus 4/5 over what? S plus 100. Alright, so now I'm going to do inverse Laplace transform. I of t equals, this is number 4, that's number 7. 1/5 plus 4/5 e to the minus 100t. And that'd be my final answer. I may have to change it after I've checked my work. I of 0 is 1. Is I of 0 supposed to be 1? Shit. I of 0 is 3. I of 0 is 3. This is 6 over 10. 6 over 10. 12 over S. Okay. S. Okay. 12. Yes. That's a 1. 6 goes into there twice, that's a 20. That goes away, that's a 1. 2 goes into that, 10. 10 times 10 is 20. Oh, I still got this 1/3 on the outside. So I do my partial fraction, that's fine, but the whole thing is multiplied by 1/3. That doesn't help any. Oh, dummy. 6 over 2. Now the 6's go away and the 2's go away. I got a 3 sitting there. Alright, that's better. I have a 3 sitting here. I have a 3 sitting there. I've got a 3 sitting here, check. Okay. Moving on to the next one. Number 20. Okay, I've got 120 is equal to 1/10 I prime plus 300 I. And I have I at 0 is 0. Okay, looks like I got, I didn't write anything except the truth, so I guess we're okay. So I got 120 over S is equal to 1/10 I of S times minus 0. So I'm done. Plus 300 I of S. I'm going to multiply everything by 10. 1200 over S is equal to I of S plus 3000 S I of S. 3000 I of S. So I have I of S equals 1000, that over S times S plus 3000. Alright, that look right? Yeah, I think I'm what, where? You got your hand up, Eric, or?
No.
No, good. Alright, so that being the case, I look at my Laplace transform table and I have a S minus that. So, in order to do number 13, which is what I'm planning on doing, I need a 3000 on top. So I'm going to rewrite this as I of S is 12,000 divided by 3,000 times 3,000 over S plus 3,000. And then we're going to use number 13. Inverse Laplace transform. I of t equals, those 0 goes away, those 0 goes away, 2/5, 1 minus e to the 3000 t, and it'd be minus 3000 t. And we already know that's not right. I of 0 is supposed to be 0, and I of 0 is 3 over 5. So that's rather hosed. What did I do wrong? Alright, did I write down the problem right? Yes, I did. Yes, I did. Okay, did I multiply by 10 every place right? Yes, I did. And an S plus 300 goes on the bottom. I have an S there, and I have that. I did that right. My Laplace transform says I need to have that on top. So I have a 3,000 there. I have to multiply by this. Okay. 1 minus e to the minus. Oh, stupid me. When was one of you guys going to tell me that I'm dumb?
Would never do that.
What's I of 0? I at 0 is supposed to be 0, and it's 2 over 5 times 1 minus 1, which is 0. Check. So when are you guys going to tell me that? Right? Because e to the whatever, e of 0 is 1, 1 minus 1 is 0.
I guess t is 0.
Yep.
Yeah.
And I was in Netherland doing something else. Okay, number 21, and then we'll call it a day. Of an RLC circuit. Okay, so I got 12 volts, and I got a resistor, a capacitor, and an inductor. Voltage across the resistor is IR. Also known as 45I. The voltage across the capacitor is Q over C, also known as 1 divided by 2 double E minus 4, 5,000, also known as 5,000 Q. And the voltage across the inductor is di dt L, and L is 0.1, so it'll be 1/10 I prime. And I is Q prime, so this is going to be 45 Q prime, and this is going to be 1/10 Q double prime. And now we're going to have 1/10 Q double prime plus 45 Q prime plus 5,000 Q is 12. And I probably don't like that 1/10 there, so I'm going to multiply through by 10 just to make things easier on myself. Q double prime plus 450 Q prime plus 50,000 Q is 120. And now we would go and take the Laplace transform of everything. Now we need some initial conditions. I at 0 is 0 and Q at 0 is 0, so all my initial conditions are 0. So I'm going to have S squared Q of S plus 450 S Q of S plus 5,0,0,0,0 Q of S equals 120 over S. So now I'm going to have Q of S equals 120 divided by S squared plus 450 plus 50,000. Oh, I wonder if that factors. I doubt it, but I think my calculator will do that for me, won't it?
You get one of those newfangled ones.
Yes, it will do that for me. So I just enter a 1, and I enter a 450, and I enter a 50,000, and I hit the solve button. Oh, bummer. Solving the wrong problem. Okay, there we go. 450. So that's better. So it's going to be 120 divided by S plus 200 S plus 250. I probably could have factored that, right? But I look at it and yeah, that's right. Okay, so, but yeah, right there it's a polynomial solver. Let's go second function, polynomial solver. I'll get on there. Go back, do something. Second function, polynomial solver. And you can have a second degree polynomial or a third degree polynomial. Just give you the words. Yeah, pathetic, I know. Just anyway. So we're down to here. We're going to do a partial fraction again and say this has to be A over S plus B over S plus 200 plus C over S plus 250. Okay, now we're going to go the other way. And I have AS squared plus 450 AS plus 50,000 A plus BS squared plus 250 BS plus CS squared plus 200 S CS. CS. And when I get done, that has to equal 120 because that's what's on top. Okay, that being the case, I'm going to look at the S squared term. A plus B plus C has to be 0. I'm going to look at this S term, 450A plus 250B plus 200C has to be 0. I'm going to look at the unit term, 50,000A has to be 120. Well, that seems like A should be 12 over 5,000. They're both even. 6 over, well, I should be able to go 4, right? 3 over 125. Yeah, so that should be what A is. 3 over that. Okay, well, that being the case, now I have two equations, two unknowns. B plus C is equal to minus 3 over 1250. And 250B plus 200C is equal to it's equal to what? Minus and 450 times 3 divided by 1250, boom, and I want that to be as a fraction, minus 27 over 25. Really? Yeah, I guess so. 27 over 25. And I also have a system solver. So right there I can go to system solver and do the same thing. So I'm going to go 2 by, this is 2 by 2, boom. Alright. So I've got X, where is it? So I've got 1, and then how many Y's do I have? I have 1, and this is going to be minus 3 divided by 1250, and then the other guy is going to be 250, 200, and the other guy is going to be 27. Oh, it's going to be minus 27. Minus 27 divided by 25. So, is that okay? So I know what A is, so now I know what B is. B is minus 3 over 250, and C is 6 over 625. Alright, so now we have to write the equation over again. So I've got, I guess I can go to black. No, I'm already in black. I'll go back to blue. So I'm going to have A, which is 3 over 1250S minus 3 over 250 divided by S plus 200 plus 6 over 625 divided by S plus 250, right? Okay. And then this is number 7, this is number 7, and this guy's number 4. And we're going to do an inverse Laplace transform of the whole thing. And we're going to get Q of t is equal to 3 over 1250 minus 3 over 250 e to the minus 200t plus 6 over 625 e to the minus 250t. Now, anybody remember what we're supposed to be doing? Find the equation of the current.
Okay.
Okay, so we have to find the equation of the current. So we're not there. We're not done yet. But Q at 0 is 0, right?
Yep.
So we should be able to check that. And so as 3 divided by 1250 minus 3 divided by 6250 plus 6 divided by 625. Is that 0? Boom, it is. Okay, check. Alright, so I of t is equal to the derivative of the q guy. Alright, so that guy goes away. The 200 goes out in front. The zeros go away. So I've got 12 over 5, maybe, e to the minus 200t plus, I'm gonna do that on my calculator. 3 times 200 divided by 250, and that's 2.4, which is what I have. Okay, and the negative sign goes away. Okay, and then I'm going to have minus, I guess, 6 times 250 divided by 625. Boom. And I'm going to have 12 over 5 e to the minus 250t. And I at 0 is also 0. Check. So I meet the initial conditions. I probably have the right answer. Okay, good enough?
Yep.
Any questions? Should we do another one?
There isn't any more.
Oh yeah, there are.
I think we're good.
Yeah, on page 1056, we could do problem number 31 and 32.
I think we're good.
Oh, right. Going from the guy that spoke first is always right. Joel is correct. And we'll stop there.
I'm correct for once.
Now that doesn't mean